In this lesson, you will learn how to factor quadratic expressions. You might recall that the standard form of a quadratic expression is ax squared plus bx plus c. Now in this lesson, you're going to learn how to factor a quadratic, so let's talk about what that means. Quadratic expressions can be written as the product of two factors. When you expand these factors by multiplying them, you get the quadratic. For example, when you have two binomials multiplied by each other, so you have 2x plus 1 times x plus 3. Now when you multiply these two binomials by each other, the answer you get is a quadratic. So you would expand these terms by multiplying, and what you end up getting is the quadratic 2x squared plus 7x plus 3. Notice how this mirrors the standard form that we have above. Now what you do when you factor a quadratic is you look at the quadratic expression and you try and figure out the two factors that were multiplied by each other to give this quadratic. So let's practice by trying a problem together. Factor the expression 6x squared minus 21x minus 12. Now remember, to factor means we want to find the two binomials that were multiplied by each other to form this quadratic expression here. So recall that the standard form is ax squared plus bx plus c. Now why I want to use this standard form is because we want to identify certain values for a, b, and c. So let me highlight them. This is the value of a, here's the value of b, and here's the value of c. So that means that a equals 6, b equals negative 21, and c equals negative 12. Now to begin factoring a polynomial, what you're going to do is find the product of a and c. That's the first step, and I'll explain why in a second. So a times c, in this case, is 6 times negative 12, right? So 6 times negative 12 gives you a product of negative 72. Now negative 72 has other factor pairs that would multiply together to form 72. So the factors that multiply together to form 72, and for right now we'll just call them x and y, right? We're going to multiply x and y to get 72, negative 72. Now these two same factors, when you add x and y, right, will give you b. So when you add the two factors that multiply to negative 72, you'll be able to find the factors should add together to give you the value of b, which is negative 21. So let's use a factor chart to help us find the correct factor pair. So here in this table, you have a multiplication column right next to an addition column. And if you notice, all of the products in the multiplication column are negative 72, since we're looking at factors of negative 72 because that's the product of a and c. And right next door is when you take those two factors and you add them together, what sum do you get? Now, the only difference between the left-hand side and the right-hand side of this column is just that it depends on where the negative sign is. So you can have negative 1 times 72, or in this case, you have 1 times negative 72. And that's going to affect the sum. It depends on which number is negative, and you'll get different sums. So we want to find the factor pair that multiplies together to form negative 72, and then when you add those factors, you get negative 21. And what I notice is when you look in the chart, you can see right here that the factor pair of 3 and negative 24 add together to give you negative 21, which means I can rewrite part of our expression. So we still have 6x squared, right? But I can rewrite negative 21x as positive 3x minus 24x, and this is equivalent to negative 21, and then minus 12. So now let's talk about what we do next. Let's just scroll down and make some space. So what I want to do is I want to group these two portions off. Plus 3x, okay? And then I'm going to put plus negative 24x minus 12. Now I'm doing this because the first two terms are positive and the second two terms are negative, so I'm just separating them that way. And because this is a string of addition and subtraction, you can just move around these terms as you see fit. So what we want to do is factor both of these binomials that you have here. So begin by looking at the first pair here. You have 6x squared plus 3x. Now the greatest common factor of 6 and 3 is 3, right? Because 3 times 2 is 6. So let's pull out a 3. When we pull out a 3, we're left with 2x squared plus x. And then you still have the rest. You have negative 24x minus 12. Now, I notice that I still have x terms, so I have x squared and x. The greatest common factor between x squared and x is x, so we can pull out another x. Now we have 3x times 2x plus 1. That's what we're left with inside. Now we want to go ahead and factor the expression to the right. So what's the greatest common factor of negative 24 and negative 12? Well, 12 times 2 is 24, so we're going to pull out a negative 12. Well, actually, yeah, let's pull out negative 12. So negative 12 comes out, and we'll just put this in parentheses for now, and then you have positive 2x left inside, and then negative 12 divided by negative 12 is positive 1. So now you have 3x times 2x plus 1, then plus negative 12 times 2x plus 1. So let's just scroll down a little bit more. We can rewrite our expression as a subtraction now because we've got this negative sign. So this will be minus 12 times 2x plus 1. Now notice what happened when we did this factoring. We ended up with the same binomial, a common binomial on each side, 2x plus 1, which means now we can factor even further still. We can say 3x minus 12 is being multiplied by the same binomial, so that would be 2x plus 1. Now when you put the 3x and the 12 together in the same parentheses, you might be able to see that you can factor this even further, that there's a greatest common factor between 3 and 12 of 3. So let's pull out that 3, and what are you left with inside? X minus 12 divided by 3, which is 4, and then 2x plus 1. So this is the answer you get after you factor the expression 6x squared minus 21x minus 12. So the factored form of this quadratic is below. 3 times parentheses x minus 4 times parentheses 2x plus 1. Let's try another problem together. Find the possible values of b if b is an integer. And here we have the quadratic expression x squared plus bx minus 11. Now remember, standard form is ax squared plus bx plus c. So we want to go in and identify some of those values. So there's no coefficient in front of the x squared, which means that a is 1. So a equals 1. Then you've got b, so we don't know what the values of b could be yet. That's question mark. And then lastly we have c, which is negative 11. So again, you want to begin by thinking about the product of a times c, and you know that the factors that multiply together to give you the product of a and c will add together to give you the value of b. So a times c equals 1 times negative 11. So when you multiply, you get negative 11 as a product. Now we need to think about the different factor pairs of negative 11. So negative 11 is an odd number, which means there are two different ways you can do this multiplication. You can have negative 1 times 11, that's one factor pair, or you could do negative 11 times 1. Now using these values, you can write the expression x minus 1 times x plus 11. This could be one factor pair, or you could have x minus 11 times x plus 1. Now when you do the multiplication over here with the negative 11 and the positive 1, you end up getting x squared plus negative 11x plus 1x minus 11. And this combines with the like terms in the middle here to x squared minus 10x minus 11. So in this case, we have one possible value of b. And if the factor pairs are negative 11 and 1, then a potential value for b is negative 10. Now let's go over here and let's see what we get when we expand these parentheses. So expanding this, you get x squared plus 11x minus 1x minus 11. When you combine the like terms in the middle, you get x squared plus 10x minus 11. So in this case, when the factor pairs are negative 1 and 11, then b is positive 10. So that means the answer to our problem up here is that b equals positive or negative 10. In this lesson, you've learned a little bit more about factoring and expanding quadratics. Thanks for watching.